So far on this toolkit of developing a research project, we have looked at how to develop research questions, critical thinking and conducting literature reviews, designing a research project and the different types of designs that can be used, approaches to research, so whether that's undertaking primary research or secondary research, different types of methods that can be used, quants, quals, mixed, resourcing projects, and then going on methods of collecting your data and coding your data. The next thing to look at is analysing the data that we've collected. So here in this slide series we're going to examine bivariate analysis techniques. Now we've talked, bivariate analysis is about techniques that allow the researcher to describe and explore relationships between two variables. Looking at the distribution of one variable in terms of its measure of central tendency, spread, shape, those kind of things, it's important, but the really interesting work happens when we examine how the distribution of one variable can affect another. What we're not interested in doing is describing and exploring everything. What is done should be theory driven, so that there is some sort of framework behind the choices that are made about what to describe and explore. When we are examining correlation, the relationship between one variable and another, we need to think about the two variables that we're examining in terms of being independent and dependent. An independent variable influences the second dependent variable, and the dependent variable is being influenced by the independent variable. So if we think of the example there of temperature, temperature will be our independent variable, and the change to the state of the liquid as a result of the temperature will be the dependent variable. We infer the causal direction based on theory, so for example age and income. When trying to remember which is our dependent and which is the independent variable, it's useful to remember time order. So independent needs to occur in a time before the dependent variable. And of course, always remember that there is a possibility of your theory being incorrect. The most common technique for describing and exploring relationships between two categorical variables, so those are normal and ordinal variables, is contingency tables or cross-tabulation. Instead of just describing the characteristics of a single variable, cross-tabulations allow us to explore the responses to a particular variable by different respondent groups, or to explore hypotheses about relationships between that and other variables. In a cross-tabulation, we place one variable in the column and one in the row. The convention is for this usually is the column being the independent variable and the row being the dependent variable. So let's have a look at an example. In this example we are looking at two variables, frequency of food shopping and gender. We are saying that the frequency of food shopping is dependent on gender, so food shopping is the dependent variable and appears in the rows, and gender is the independent variable and it appears in the column. Here we can see, if we have a look at our frequency table, we can see that we have our daily several times a week, several times a month and several times a year or less. We have that split by male, female and total. We have a number of different totals. We have our row total, so this gives us the total number of responses to daily, that being 40 for male and 55 for female, with a total of 95. We also have a column total, and that is a total for each of the columns, so we have a total of 121 responses for males, 151 responses for females, and then of course we have the grand total. The grand total is our total of the number of people, a number of respondents, so 121 males and 151 females, that's 272 people. And we can calculate it the other way around as well, so the total number of people responding to each particular category. As with all tables, counts in themselves are useful, but it is the percentages that allow proportions to be seen. The counts enable us to calculate percentages. Within crosstabs, this is calculated using three ways: using the columns, using the rows, or using the totals. So in this example here, we're going to have a look at calculating our column percentages. So for males, how many go shopping for each frequency level by the total number of male respondents. So we can see here that there were 121 male respondents. Of those, one third or 33.1% responded that they go shopping daily, 46.3% several times a week, 16.5% several times a month, and 4.1% several times a year, and the same for females. If we look at row percentages, we can see that the percentages have been calculated using rows. So of those who go shopping daily, how many are males and how many are females? So we can see that there were 95 people who went shopping daily. Of those, 42.1% were male and 57.9% were female. And you repeat the process through the different categories. And when you get down to the bottom, you can see a total, and you can see there were a total of 272 respondents in total. And of those, 44.5% were male and 55.5% were female. In this example here, we can see that the cross-tabulation we have used total percentages. So each count is divided by the total number of respondents. So the total number of respondents is, say for example, so it means that if we take that percentage of 14.7, it means that 14.7% of the total number of respondents were male and shopped daily. Okay, 20.2% of the total number of respondents were female and they shopped daily. So it gives you the row, column and total percentages. They give you a different look at the same data, and it depends on what it is that you're trying to say. Now, when presenting our data from cross tabulations, we can present it in a multiple bar chart, and we have an example here. So multiple bar charts can be displayed as either a count or as a percentage. In this example that we've got here, we're actually using percentages. And here the percentage is actually based on a row percentage, and that shows that 42% of those who shop daily are males and 58% of those who shop daily are females. In order to explore the relationship between two variables, we're looking categorical at the moment, it's useful to start thinking about why the relationship exists, how the variables are associated, and whether there are any other variables that may impact on that relationship. To do this, we use what we call elaboration analysis, and that is the extent to which a relationship is affected by the introduction of another variable. Elaboration analysis then is about exploring the extent to which a relationship is affected by the introduction of another variable, and you're asking questions about whether a relationship will still exist and to what extent if we introduce another variable. So if we go back to our example of food shopping, so is the frequency of food shopping affected to the same degree when another variable such as employment status is introduced? When we're dealing with this kind of analysis, we always have to be mindful of what we call spurious or false relationships. Spurious relationships are when an association has been made between two variables that is actually not due to a direct cause and effect relationship, but is actually due to a third known or unknown variable. With elaboration analysis, if we add a third variable, it actually allows us to build a more complex picture of data, and it allows us to consider possible spurious relationships as well. So it almost sort of enables us to test for spurious relationships too. An example of a cross-tabulation. This is an example of what we mean by cross-tabulation of three variables. So here we can see we have our independent variable. We've got gender here, but we're actually looking at frequency of food shopping by employment status, by whether you're employed full-time or whether you're employed part-time. So in that sort of large top row, we're looking at people who are employed full-time and what their shopping frequency is and splitting that by gender. And for the bottom one, we're looking at those people who are employed part-time and we're looking at their frequency of shopping and we're looking at that split by gender as well. And you can see that we have a number of different proportions that we're calculating there. And again, you can do exactly the same. You can calculate your percentages either by rows, columns or by totals, and this will give you different answers.